This is Module 8, Lesson 1. This can be found on page 234 of your book, and Lesson 1 is called Understand and Apply Exponents. Now, we're going to start right up over here with this 2 and this little 4. This is called a power. In a power, we have a big number and this little tiny number. If we look down here, the big number is called the base, and the little number is called the exponent. So, the base of a power is the factor that is multiplied repeatedly in the power. The exponent of a power is the number of times the base is used as a factor of repeated multiplication. And what that means is, I'm going to look right up here above that. The base is 2. The 4 tells me how many times I'm going to write that 2. So this is not 2 times 4. This is 2 times 2 times 2 times 2. Again, this little tiny number right there, that exponent, is a 4. It tells me how many times I'm going to multiply that 2. So 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. It is not 8, it is 16. The exponent does not say, hey, we're going to do 2 times 4. It means we're going to be writing out 2 4 times. Okay, let's take a look down here. We're going to write products as powers. So we're going to go the opposite way, and we are going to take this long thing and we're going to turn it into something that looks like this power with the base and an exponent. So 7 is written there, so I'm going to make my 7 big as my base. And then 7 is written 1, 2, 3, 4, 5, 6 times. So our exponent is 6. 7 to the 6, and that's all we're doing. We're not solving it. That's it. This is 9, so our big number, which is our base, is 9. And then we're going to count how many 9s there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 to the 9th. And we have 4 times 4 times 4. So my number is 4, and that 4 is written 1, 2, 3 times, so 4 to the 3rd. This time they're giving us our power, and we are going to go the opposite way. Now, I know you have a calculator, and yes, you're able to use it on here, but look to see what I'm required you to have down. So 6 squared, this 2 means I'm going to write the 6 twice. So I have 6 times 6, which is 36. 10 to the 1, that just means I have 10, that's it. I only am putting it there one time. Okay, now if you're putting this in the calculator, you do need to put the parentheses around your 1/2. I'm going to do 1/2 5 times, so I'm going to write it out 5 times. 1/2 times 1/2 times 1/2 times 1/2 times 1/2. Now, if I'm going to put that on my calculator, I'm going to write it as a fraction as 1 over, first off, open parentheses, 1 over 2, close parentheses. We're going to use our little caret button that looks like a triangle without the bottom on it. And we're going to put a 5 next to it. So, in your calculator, it should look like open parentheses, 1/2, close parentheses, caret 5. And I get 1 over 32 as my answer. Our next one is 3 to the 9th. This 9 means I'm going to write out my 3 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if you run out going straight in a row, you can go down below it. So my calculator, this is what it's going to look like in your screen when you type it. 3 to the 9th. And I get 19,683. Let's take a look at the next page. A dot is sometimes used instead of the symbol times. So instead of the normal multiplication x, we can also use a dot. you can use an exponent and a base to show repeated multiplication of a factor. So unlike what we did over here, when I wrote out the times sign every single time, we could have just put a dot between it and saved us a lot of time. Let me zoom back in on that so we can see it. So 7th to the 5th power, that means 5. So I'm going to write out 7 5 times. I'm putting a dot between it. And that also means multiplication. Our base is 7 because that's the number written out. Our exponent is 5 because that's how many times 7 is written. Now, make sure that dot is high enough up so it's not can be confused as a decimal. Let's look beneath that. There are two specially named powers. 8 squared could be read as 8 to the 2nd power or as 8 squared. This one right here could be read as 9 to the 3rd power or as 9 cubed. An exponent tells us how many times the number is used in an expression. Look at this expression. 5 times 5 times 5 times 5. How many times is the factor 5 used? And if we look at it, it's 1, 2, 3, 4. So 4 times. Complete each statement. So this little box, it should be a little bit smaller than what it is. It's going to show us the exponent. So we have 5 times 5 times 5 times 5. So that's 5 to the 4th. Here, 1, 2, 3, 4, 5, 8 is written 5 times. So 8 to the 5th. This 1/3 didn't come out very nicely for us, but we can still be looking at it. I have 1/3 to the 5th. That means I'm going to write 1/3 out 5 times. And right now, not sure why that box didn't show up, but we write it one more time because it's 5. It did not ask us to solve it. It just asked us to write out the repeated multiplication. Find the value of each expression. 5 to the 3rd. 5 is our base. 3 is the amount of times we're going to write it. So 5 times 5 times 5. In your calculator, you'll put it as 5, this little caret, 3. So 5 to the 3rd. And when we do that, we get an answer of 125. 4 to the 5th. The base is 4 and the exponent is 5. Since the exponent is 5, we're going to write 4 out 5 times. But we are missing a box, so I'm going to make that up for us. 1, 2, 3, 4, 5. So in our calculator, we're going to be typing 4 to the 5th. And I got 1,024. Now we're on check understanding. If you're doing this in your book, you'll find it on page 235. Let's start with the first one right over here on the left. A farming community begins with 1 resident. Then, every year, the number of residents multiplies by 10. Write an expression using an exponent to represent the number of residents in the community after 5 years. So we're going to start with our 10, because if we're multiplying by 10, that needs to be our base. And 5, so 10 to the 5th. And all of it says that we need to write an expression. That is our expression. If they wanted you to write it out, you'd write it out as 10 times 10 times 10 times 10 times 10. But we don't have to worry about doing that. All you need to do is 10 to the 5th. On a tree, the trunk splits into 5 branches. Then each branch splits into 5 smaller branches, and each of those branches split into 5 very thin branches. How many very thin branches are on a tree? So I know we're going to be multiplying by 5s. Let's see how many times. We have 1, 2, 3. So 5 to the 3rd, which is 5 times 5 times 5, which is 125. If you want to label it, that's thin branches. Let's look up here at the next one. Explain the expression 2 to the 10th. Complete the sentences. The number 2 is used as a repeated factor 10 times. So 2 is the base, 10 right there. The base of the expression is 2, and the exponent is 10. And the value of 2 to the 10th is, we type that into our calculator, it would look like this, 2 to the 10th, and that will get us 1,024 as our answer. And our last one on tech understanding, a certain bacterium splits itself into 2 identical cells in 1 day. Each of those cells is capable of splitting itself into 2 identical cells in 1 day. So the first day there are 2 cells, the second day there are 2 times 2, and so on. Write and evaluate an expression using a base and an exponent to represent the number of cells present at the end of the 7th day. So it's going to be 2 to the 7th because we're doing it 7 days. It doesn't say that. And so 2 to the 7th, I'm going to write that as 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7. I'm going to put 2 to the 7th in my calculator. And I got 128 cells. Hey, here's what do you remember? You can find this on page 230, some of them on page 236. Zoom in so we can see it. Remember, if you're doing this by yourself, try to do them without me and then go back and check your answer. Write each expression in exponential form. So all we're going to do here, we have our base of 9, and it's written 1, 2, 3, 4, 5 times, so 9 to the 5th. Here our base is 1/8, and we're going to put parentheses around them and put a 3. The reason we put parentheses around them when we're doing exponents on a fraction is otherwise the 3 could just go to the 1 on the top instead of the whole thing. Write the exponential expression as an equivalent repeated multiplication expression and then evaluate the expression. So that's a lot of stuff, but it's actually super simple. We're going to take 6 to the 3rd. We're going to write that out as 6 times 6 times 6. The base was 6, so we use 6. We put 6 3 times because the exponent is 3. So in our calculator, we're taking 6 to the 3rd, and I got 216. 2 to the 6th, our base is 2. 6 tells me I'm going to write out 2 6 times. So 1, 2, 3, 4, 5, 6. In my calculator, I'm typing 2 to the 6th, and I got 64 as my answer. Explain the expression 10 to the 5th. Complete the sentences. The number 10 is used as the repeated factor. 10 is used as a factor 5 times. 10 is the base, so that's the number you're multiplying, and then you have to do it 5 times because the exponent is 5. Carrie recruits 3 of her friends to sell candies to raise money for new playground equipment. The next day, each of her 3 friends recruits 3 more friends. The pattern continues for 5 days. Write an exponential expression to represent the number of new recruits on the 5th day. So she does 3. So the number 3 is used as a repeated factor 5 times because we want to find the 5th day. So now we're going to write that out. So that would be like 3 to the 5th. So 3 is going to be written out 5 times. So 3, 3, 3, 3, 3. In our calculator, we would type it as 3 to the 5th. And they didn't ask us to solve it, so this is actually, because it says write the expression with an exponent. So this is the answer. They didn't want you to solve it, so you didn't have to type in your calculator. Some of you might have already, though. If you ever need to go back over this lesson to make sure you have a better understanding, you can do that. There's also lots of great videos on YouTube and games online if you need to do more work on powers and exponents and bases.